Okay, welcome back. So let's just continue on with the last one here. Now, this one looks a little bit different in that you have x minus 5 all squared. You don't have two distinct factors or brackets written out right now. So what I am going to do, just recognize when you have something that's all squared, it's really just multiplied by itself. So I have 2 bracket x minus 5 bracket x minus 5. Now again, this looks a little bit strange because, if you want to find the x-intercepts, well, since each of these brackets are the same, they're each going to produce the exact same x-intercept. In this case, when you have x minus 5 being equal to 0, you wind up with an x value of 5. Okay, so there is only one x-intercept here. So think about how this probably would have to look for it to only have one x-intercept. Well, so you probably thought of a few different options in your mind. Well, the main one that comes out, well, if you take a look at what this graph actually looks like, if I have y equals 2x minus 5, sorry, 2x minus 5 squared, well, if we take a look at our graph, you'll see that in order for the parabola to have only one x-intercept, it means the vertex is on the x-axis. So it comes down, just touches at the x-intercept, in this case is 5, then continues on back up. So this only has one x-intercept, and that's what it means about the vertex. It happens to be at the x-intercept. So if we go back to our example here, we'll deal with the y-intercept later, but for our axis of symmetry, if I know the vertex happens to be at 5, 0, okay, because it has to be at that x-intercept, okay, well, my axis of symmetry has to be x equals 5. Okay, so just the fact that I have only one x-intercept tells me that the vertex is there. So just from that information, I get the vertex, which will also give me the axis of symmetry. Okay, for my y-intercept, I can do exactly what I did before. Okay, I can sub in x equals 0. Okay, so if I do that, I'm going to get y equals 2. 0 minus 5 is negative 5. And that's squared. So negative 5 squared is 25. And 25 times 2 is 50. So that's my y-intercept. Okay, so that's that one. And again, you could do a quick little sketch here. What you're going to have is you're going to have the vertex over here at 5, 0. Okay, we open up, and we're going to have a y-intercept of 50. So not a super fancy sketch here. Just a parabola that's just touching the x-axis once. Okay. So let's move on to a different type of problem here. Now we've gone from being given the equation to find all sorts of information. Now we're going to try and go backwards. We're going to be given a graph and try and find the equation of it. So the one thing I'll note here, there are infinitely many quadratics that have the same x-intercepts or zeros. So depending on the stretch factor, which comes from that a value, okay, these are all going to belong to the same family because they all have the same x-intercepts. However, there's going to be an a value that will give it a different stretch or compression factor. It'll tell you how wide or narrow the parabola is. Also might tell you if it opens up or down. So what we want to do is actually figure out the equation of the quadratic that creates this exact graph right here. Now it says I want the answer in both factor and standard form. Let's just do one at a time here. Now if you look at this graph, what can I get from it immediately? Well, the y-intercept doesn't look very exact right now. The vertex doesn't look very exact right now. We'd have to estimate it, but I can get the x-intercepts exactly here. There's one here at negative 7 and one here at 3. So we're trying to work backwards now. If I wanted to create factored form, if I was to have an x-intercept of 3, well, that would have to come from a factor or a bracket of x minus 3. Again, so if I put x equals 3 into this equation, I should get the whole bracket or factor to be equal to 0. Okay, so similarly, if I look at x equals negative 7 as an x-intercept, this would come from a bracket or a factor of x plus 7. Okay, now you might think that we're done here, but we're not, because I mean, let's just take a look at here. If I were to plot on Desmos x minus 3, x plus 7, okay, this does not look remotely like the parabola that we have. Okay, the one we have opens down, this one opens up, nothing's the same. And it's because we haven't thought about that a value in front, that stretch or compression factor. So depending on what value I have here for this a in front, I can have a parabola that's narrow, wide, opens up, opens down. You'll notice that every single graph that's coming up here on this screen, what doesn't change is the y-intercepts. Those are always going to be at -7 and at 3, regardless of what I do to this a value. But there's only one specific a value that's going to create the exact graph I want, which is this one right here. So there's some a value here I don't know. We have to actually somehow solve for it. Okay, so in order to do that, I'm going to look at this graph and say, okay, I know my x-intercepts are at 3 and -7, so I've incorporated that into the equation. I must know some other point that this equation passes through. So if I look on here, right over here at 1, 8, I have a point that I know this parabola passes through. So what I'm actually going to do is I'm going to take that point, because that's really just an x and y value, and sub it in here for x and y. So I'm going to sub in the point 1, 8 for x and y. So I'm going to replace every x value I have with 1, every y value I have with 8. Let's see what happens. So y becomes 8. Still have an a value. I get 1 minus 3 and 1 plus 7. Okay, so from here, once I've done this, I see the only unknown left in the equation is my a value, so I can actually solve for it. So I get 8. Here I get -2 and +8. Okay, this is multiplication, so I get -16a on the right side of the equation, 8 on the right. So when I divide both sides of the equation by -16, I end up with an a value of -1/2. Okay, so now that I know that a value, I can put it back in here to actually get my equation in factored form. So I'm going to do that up here and say, hey, there's my equation. Okay, so that particular a value will produce the graph that I've given you. Okay, no other a value will do that. So the a value here is unique to this particular graph. Okay, so again, just to recap, I use my x-intercepts to create my two brackets or my factors. I have to solve for my a value. Every single time I'm going to need to solve for that a value. I'm going to do that by subbing in a point that I know that parabola passes through, subbing that in for x and y, solving the equation for a, then creating my equation. Okay, once that's finished, I want it factored form and standard form. So I'm going to let you guys, as practice, expand and simplify to put this in a standard form. So I'll do it on my own here, you do it on your own. Pause it for now and push play when ready to see the answer. Okay, so in order to expand this out, you should have taken the x minus 3x plus 7 and used an array or distributive property to expand this through. So I did that over here, x minus 3x plus 7, multiplied to fill in each box of the array, so I wind up with x squared plus 4x minus 21. And once I was finished that, I still have my -1/2 hanging around out in front. So I need to expand that through the bracket. So if I do that, I get -1/2x squared minus 2x plus 21/2. Okay, so now I found that equation both in factored form and in standard form. Okay, so I know there's some other examples left in this lesson, and you're welcome to try them on your own, but I actually think this is a good place to stop for today. We're going to do these another day, but I'd like you to start working through this homework. You can do most of it right now. Primarily, I want you to start with completing this table here. So I've given you two equations in factored form. I want you to find the equation in standard form, then find all these features of the graph as well. And you should be able to do most of what's on page 156 and 167 right now as well. So we'll do the rest of this lesson, the examples, tomorrow, but this will be a good stopping point and give you a chance to practice before we move forward. Okay, thanks a lot. Cheers.